Today, we are designing a macro slider from scratch, integrating standard off-the-shelf parts. Welcome to Design Bits, a collection of projects too detailed for a vertical video, but too quick for a deep dive. I want this format to be raw, technical, and straight to the point. To kick off this new series, we're firing up the newest addition to the studio, the Prusa Core 1 Plus, and I'll be putting it to the test with some technical filaments today. This project was born from my need to shoot macro footage to show you exactly what's going on up close. But the trade-off is a super shallow depth of field. Your entire range of focus drops to a range of millimeters. Basically, a macro slider allows very small adjustments of the camera position without constantly fighting the tripod. Let's see how it came to life. I decided to use mostly standard components from the 3D printing world, taking inspiration from other amazing projects. Everything sits on a 2020 aluminum extrusion, the perfect structure for an MGN-9H linear rail. Jumping into the CAD, I can also add the T8 lead screw to lay out the main hardware. Since precise positioning is crucial for a slider, an anti-backlash nut is essential. I accidentally ordered the wrong pitch, but it turned out to be a great opportunity. I designed it myself and printed it using self-lubricating August filament. I'm impressed by the smoothness and zero play achieved. Let's assemble the first PLA prototype, starting with the brackets that hold the lead screw. Now, it's just a matter of connecting the nut to the rail. Shaft collars keep the lead screw centered. And the concept is approved and working. After a couple more reviews, I'm ready for the final assembly. Since I value my gear, I'm printing the final version on my Prusa Core 1 Plus using Saraya's Tech PPA-CF core. If we get closer, you can see the higher fiber density at the core of the filament. Let's see the improvements. I enlarged the brackets to cover the profile ends. They are no longer mirrored, and you'll see the extra functionality later. Rather than reinventing the camera mount, I'll integrate this standard mount clamp and reverse engineer it into the CAD. The central block is the main upgrade. It now features a custom slot to perfectly hold the camera clamp. We now need a knob to manually drive the slider. I'm using the same concept Voron uses for the M4. A pulley grabs onto the lead screw and the flange is popped off. Then the 3D printer knob slides over it, a couple of screws thread on the pulley, and we're done. We have a custom sturdy knob using standard parts. One last thing I want to fix. The anti-backlash nut works perfectly, but we still have a tiny amount of play due to the clearance between the collars. If we zero this gap, the backlash disappears, but small misalignments make the rotation not that smooth. So let's scrap this collar and swap it with a custom spacer that interfaces directly with the bearing. On the other side, we add a spring that's kept compressed by the pulley. And just like that, we have a second anti-backlash system and a really smooth rotation. I also added notches on the knob that interface with this arrow indicator. Every movement from notch to notch corresponds to a 1 mm linear movement. The slider is done. I used it to record the macro shots you've been watching throughout this video. I'm really enjoying this tool. The open source community gave me so much. It's my turn to give back. That's why this slider is fully open source. You can find the digital files and the complete hardware list down in the description. I hope you enjoyed this first episode of Design Beats. See you in the next one. Ciao. These composite fissures, mamma mia.